I mean the total number of atom present in FCC. FCC means the face centered cubic cell. How many atoms are present? 4. In body centered, okay. How many atoms are present? Only 2. Okay. And if we talk about the simple cubic, I mean it's a basic primitive, then it has only the one because there are only the corners where atom can sit and nowhere else, right? So obviously, if number of atoms is present is more, the you know the amount of the volume occupied by the atom would be more simply, right? And if you calculate the way I have asked you to calculate, I mean the efficiency, okay, the 64%. How you can calculate? Simply the volume that occupied by the packing fraction, the packing efficiency. Okay, it's very simple. The amount of the volume. I mean, you can exactly write. This is the volume by volume of cube. Okay, so volume of cube is at denominator and volume of total volume of occupied by the atom. Okay, so total volume occupied at the numerator and the volume total volume available is at denominator. Now this ratio is known as the packing efficiency. Okay, so once you will calculate the value of the total volume and divided by keep it in the denominator, and for each and every unit cell you need to calculate these two and just take the ratio of these two, you will have the packing efficiency. So in FCC you would have the 74% of this value. Okay, and in BCC you have 68%, and if we talk about the first one, I mean the simple cubic, then you would have only 52%. Got it? I have already made the coordination number. How many atoms they are sharing to the neighboring atoms is known as your coordination number. Okay, so I mean look here about the ductility. Ductility means there are two terms: ductility, I mean ductile and brittle. Okay,
Elongate.
yeah, yeah, good. So I mean if you apply the force, okay, they will uh, elongate too much before breaking, right? Before fracture. But in a ductility in ductile material, if we talk about the brittle materials, then it will break suddenly without giving a elongation, right? This is a basic difference. Okay, you can say, I mean, you can have the different properties as well, but in more or less we can simply think about. I mean, ductility means they can elongate easily. Okay, before breaking. I mean, how much elongate? Obviously, before breaking, every material has their own capacity. Till there, they can elongate. Otherwise, they cannot. Right. So every material has their own kind of capability of elongations. So it's better to say, I mean, elongation before break. But in a ductile, sorry, in a brittle, before, I mean, it will suddenly break down. Okay, into forms. Okay, so if we talk about the ductility, see here, it's a high, it's a moderate. Okay, here it is low. So why it is? I mean, the same shape, same things, but what is the difference? Difference is the present of number of the atom present and the places where it is present. As you can see, here's a four atoms. It means number of the atoms present is more. What does it mean? The volume occupied by the atom is more. It means they will provide the more ductility, right? Because the atoms are closely packed, they are close to each other. They will have the strength to repel the strength. I mean the force. Okay, so they will combinedly together. They will have either sufficient elongations. Okay, so number of atoms present more, then it will have the more ductility. It means just opposite to that. If we talk about the hardness, I mean brittleness, then it will have the less brittle. Oh, sorry, yeah, less brittle. This is moderate, and this is the high brittle, right? So just opposite to the ductility, there is a brittleness, right? So I mean, you can just directly correlate with the number of atoms here present. See here, 4, 2, here is a 1. Got the idea? So number of atom is basically directly, I mean, it's just a simple one example. Okay, I mean now you can think about if I mean the if we will categorize the materials, then we have the broadly we can categorize in two forms: a brittle material and ductile materials. So the material category is basically defined by the you know the unit cell, which we are not known about in bulk when we see bulk material, but how they are behaving, how they have been categorized. Okay, that you can see here. So the unit cell basically define the whole which material is of which kind. Okay, so I mean this is the ductility and brittleness. Okay,